Hello, ladies and gentlemen. Welcome to the Radicals Review. We're going to learn how to simplify radical expressions, and in a different video, we'll talk about rationalizing. So let's move on right here. So here's the radicals overview. You have the Latin word for root, and there are two parts to the radicals. You have the radicand, which is the expression inside. Now, we're going to particularly focus on numbers as opposed to variables in this class. So thank goodness for that, right? And then we have index, which is the degree of the root. So the degree will affect what type of radical you're going to tackle. So for example, let's say we have the square root of 9. So this is a basic radical sign. If there's no degree number there, that means you can assume it's a square root. And all it's asking is this: what number times itself would equal 9? Well, in this case, that would be 3. 3 times 3 is equal to 9. There's your answer. However, if we had a cube root of 8, then the question is asking what number times itself 3 times. So 2 times 2 times 2 would equal 8. So the answer is 2. Now, thankfully, we also don't really need to worry too much about cube roots. In the future, we will come back to that, but particularly, we're going to focus on square roots. So let's move on to the next slide. So this video is going to focus on the highlighted part right here, where it says the expression under the radical sign has no factor. That is a perfect square. In other words, we're going to get it in its simplest form. So here are some examples we're going to tackle. We have the square root of 24, 75, and 32. We're going to get these in the simplest form. But before we do, for a particular form of students of mine, you guys would have learned it in a particular way, where you would break it down using tree factor and circling pairs and stuff. But now that you're in this class, you're going to use the more efficient way of finding the largest perfect square or perfect cube. I'm going to go to the slide right here. So this list right here is what you're going to memorize or learn. Now, some of you are thinking, how the heck am I supposed to remember all this with all the other stuff I have to learn? But there's a trick to it. The perfect square is all it is you start with the first counting number, which is 1, and then you just square it. So 1 squared is equal to 1. To get 4, you do 2 squared. The next one is 3 squared. 4 squared. So you just go up the counting number and you square it, and then that's how you get your perfect squares all the way down to 12 squared to get 144. I have the perfect cubes listed down here, and that one is where you would cube the numbers. Now I'm just trying to introduce this so that some of you that are familiar with it, you would at least remember that this will come up in the future. But for now, we're not going to worry too much about it. We're going to focus purely on the perfect squares. So going back to our examples, we have the square root of 24. Well, we have to take that list we had, and we have to figure out, okay, what is the largest perfect square that can go into 24? So what I'm going to do is I'm going to list all my perfect squares on the top. So 1, 4, 9, 16, 25, and then I'll stop there because I can't divide 24 by a number bigger than itself. I got to do something smaller. So I start with 16. Can 16 go into 24 in even amount of times? No. Does 9 work? No. 4 does. So what we're going to do is we're going to split this square root of 24 into 2 radicals. Well, we already know one of them is 4, so now we ask ourselves, how many times does 4 go into 24? Well, that is 6 times. Now that we've established that 24 splits into 4 and 6, now we say, all right, well, since this 4 is the largest perfect square, we already know that that's going to be 2, and the square root of 6 can't be broken down any further. Therefore, this is our final answer. Let's try another one. Square root of 75. So now I have to expand my list. So after 25 is 36, 49, 8 squared is 64, 9 squared is 81. So there's our largest perfect square up to 81. Now we start asking ourselves, what's the perfect square? It's the largest one that can go into 75. So we start with 64. Doesn't work. 49 doesn't work. 36 doesn't work. 25 does. Now some of you might have just seen it and like, hey, well, 25 is a quarter. That goes to 75 cents, which is 3 times. So if you see it right away, go ahead and do that, but this is more for you guys who still need to kind of get a grasp on how to use this method efficiently. So 25 is the largest perfect squared. Well, 25 goes into 75 3 times. So there's our two radicals split apart. And we know that the square root of 25 is just equal to 5 because that's our perfect square. And then 3 stays the same. Square root of 3 stays the same. And therefore, this is our final answer. So see how this is a lot more efficient than using a tree factor, which can get muddled, and you can get lost in those steps. So it is nice to use that method because it breaks everything apart. But again, this is the more efficient method. So let's go to square root of 32. We break this apart. The largest perfect square. So we say, all right, what's smaller than 32? 25. 25 doesn't work. 16. 16 does. So we're going to split this apart. Square root of 16. How many times does 16 go into 32? 2 times. And then we say, hey, square root of 16 is 4. Square root of 2 is done. And there's our final answer. So there you go, ladies and gentlemen. That is how you simplify radicals, specifically square roots. So if we go to the next slide, not that one, this one, this is where I would like you guys to practice on your own. So take this time to pause the video right now, and then when you're ready, you can go ahead and check your answers. Okay, so pause right now. You've had your chance. Here you go. Check your answers here with mine. I'm just going to show you all the work right here. So nothing particularly crazy. I mean, you have the square root of 98, less than 49 to 2, and then get 7 square root of 2. And then the rest of the work is right there. And there you go, ladies and gentlemen. That is simplifying radicals. Check out the next videos on the 2 other parts on radicals.